All right, so tonight I'm going to talk to you guys about exoplanets. And usually when I open up a talk, I'll... oh, by the way, my name's Jolyon Johnson. You can just call me Joe, but there's my name. Don't wear it out.
What's the derivation of that first name
anyway?
Oh,
It's actually a combination of John and Julius. So I'm not sure what that's going on, but anyway, it comes from... Yeah, I know. But it comes from a book called The Forsyte Saga that was written by John Galsworthy. It's kind of a... It's just kind of like the Great Gatsby. Anyway, so I usually open up my talks with some kind of news from astronomy, but this is so exciting and so earth-shattering, almost literally, that I'm going to wait till the end for this one. So what we're going to cover tonight is the history of exoplanet discovery, which is extremely important, notable discoveries, so these are going to be the most important ones, and in that I'm going to tell you sort of the classifications of different exoplanets. And then I'll cover the methods used, the most common ones. And then we'll talk about the results from the Kepler Space Telescope, which is the exciting part. And finally, we'll actually have more of a discussion of the implications of the Copernican principle, or on the Copernican principle of those discoveries. All right. Oh, they flashed someone. All right. So what is an exoplanet to start off with? Well, it's short for extrasolar planet. And you can probably figure out from that it's a planet that orbits a star other than the sun. So what makes a planet? We all remember what happened to Pluto, right? It's not a planet anymore? Well, of course, it wasn't destroyed. Yes, poor Pluto. Yeah, whatever. So it wasn't destroyed. It was just reclassified as a dwarf planet. So a planet and a dwarf planet as well is massive enough to have achieved hydrostatic equilibrium. That's a really fancy word for saying that's a ball. It's basically a sphere, like the Earth. And Pluto classifies for that. However, it also must be massive enough to have cleared its orbit so that it has not, or so it doesn't cross its orbit with other planets or objects of a similar size. So what that means is the main planets like Mercury, Venus, Earth, and Mars, Jupiter, Saturn, Neptune, and Uranus. Uranus and Neptune, so I got that backwards. Yeah, have more or less spherical orbits. They don't cross their orbits. However, Pluto crosses Neptune's orbit. So for a brief time of about 20 years in its orbit, it's actually closer to the sun than Neptune is. So it's kind of the eighth planet, or was the eighth planet for a while. The other thing is, I skipped that one, that it has to not be massive enough to begin fusion. So some of you may have heard the myth that Jupiter is kind of a star that failed. Hey, Hassan, how's it going? He's kind of the headmaster of Aristotle's Cafe, by the way. So wave. Yeah, that's Hassan.
I'll make it back there.
All right, cool. It has to have not been massive enough to begin fusion. So you guys have heard the myth of Jupiter being a failed star? Well, it kind of isn't, because it's not even close enough to being massive enough to begin fusion, which is, of course, the definition of a star. You know, the sun has fusion in its core. That's what other stars have as well. So currently, that value is calculated to be somewhere around 13 Jupiter masses. That's kind of the limit. And there are some planets, exoplanets, that are right at that cusp that have been knocked out of that category because they're at 14 Jupiter masses or something like that. So that is the definition of an exoplanet.
So, but being 14 Jupiter masses doesn't necessarily mean a fusionable star.
Exactly. What could have happened is that it once had fusion, but it's already fused all of its deuterium, but it's not massive enough to begin fusing helium or carbon or some of these other higher elements. So it's already like burned out. It didn't like go supernova or anything like that. It just kind of fizzled out, and now it's kind of like a gigantic Jupiter. So the first guy to propose exoplanets that I know of, I mean, I'm sure that there were Greek philosophers that would talk about there being planets out there, but the first guy to really put it forward and make a name for himself for saying it was this guy, Giordano Bruno. How many of you folks have heard of him? All right. Yeah, this guy, he's one of the most important philosophers in science, believe it or not, because he was the pre-Copernican guy who said that there are planets orbiting distant stars. And he said that along with several other things about the universe, like saying that it was infinite in size, like saying that the distant stars were really distant suns. He said that comets were not really just things we should ignore that are interactions of the elements. Really, they are big rocks floating through space. He said that, and for that, you can guess what happened to him at this time period here. Indeed, he was burned at the stake for saying those things that we now know are true. 400 years later, the Catholic Church did apologize for that, and this is his statue that is facing the St. Peter's Basilica. So the first exoplanet that was actually discovered was this one right here. There's a really catchy name. It hasn't been renamed since then. PSR B1257 plus 12.
Is that a Stargate address?
I think so. So it's orbiting actually a pulsar. That's what the PSR stands for. And this is the first exoplanet. Actually, there are 3 of them in the system that are confirmed. And they're actually around Earth mass or a little bit larger. And it's amazing the way that they discovered it. The orbit of these planets actually kind of disturbs the rotation of the pulsar, so its timing is off. And pulsars rotate at extremely precise times. You can time them down to billions and billions of a second of time in their rotation. So when it was discovered that there was an oddity in this one's rotation, they derived the masses and the orbits of these planets. And what's fascinating about these ones is they're really close, and they're made of, it's believed they'd be made of exotic material. And it's thought that what actually happened was the star that created the supernova, or I'm sorry, the pulsar, went supernova, and all the remnant matter from that supernova actually reaccreted and returned into a new stellar system. However, of course, the problem is that this is not a star that is currently undergoing fusion. If it's a pulsar, it's just a giant ball of neutrons, basically, that's spinning really, really fast. So it doesn't really quite count. And this happened in 1992. It wasn't until 3 years later that this guy had the brilliant idea of using the rate of velocity. I'll go over the method later that he used to discover an exoplanet. But he received enough funding to go ahead with his project. Everyone called him nuts. He said, "You can't do that. It's not going to work." But in fact, he did find an exoplanet called 51 Pegasi. However, his project was scooped by a couple of guys in Switzerland. They heard of his idea, and they said, "Ooh, we have some cheaper stuff that we think can do it too." So the Swiss in Geneva, these 2 guys, I can't pronounce his first name, maybe you guys can, and Michael Mayer, Didier Quetzalcoatl or something, for those of you who know the Mayans, or the Aztecs. They came up with an idea that was a little bit cheaper than what Jeff Marcy had in mind. And they discovered the planet 51 Pegasi before he did. Now, going back to Jeff Marcy, however, this fellow has actually today discovered more, well, until a couple of weeks ago, had discovered more exoplanets than anyone else ever had. He had somewhere around 70 or 80 to his name. And now he, because of his experience with exoplanet discovery, he has basically unlimited time on the really big telescopes, like the Keck Observatory in Hawaii, those really big, like 10-meter ones. So he's discovered all kinds of exoplanets. He's a real guy at the cutting edge. However, what's really amazing about exoplanets is it's a relatively recent field. The first ones that were found orbiting around regular stars, which was 51 Pegasi, was in 1995. So it's a really new field that's just exploding. And I'll get to this later, but it's accessible to just you and me. Honestly, it really is. I'll get to that later, though. So Jeff Marcy is kind of the guy right now in exoplanets. So the first kind of exoplanet to be discovered, and it makes perfect sense why it would be, is things called hot Jupiters or super Jupiters. And what they are planets that are a lot like Jupiter. They're made of gas. But they're extremely large. They're extremely massive. So that would be less than 13 masses, but greater than a Jupiter mass. So these were like around 5 Jupiter masses, the first one. But what was really odd about them that no one expected was their orbits. See, Jupiter goes around the sun every 100 years, and somewhere around that many years. And these planets, these first ones like 51 Pegasi, just whip around their planets in a matter of days. Literally.